Hello! So in this video we're looking at section 5.1 and we're solving systems of linear equations by graphing. And a system of linear equations just means that we're going to have more than one line on our graph. Okay, so we're looking at our learning targets first for the video. And at the end of the video you will be able to check solutions for linear equations, and you will also be able to solve systems of linear equations by graphing. So our core concept that we're looking at when we solve a system of linear equations by graphing is going to follow these three steps. So go ahead and take a minute and copy these in your notes. So step one, we're going to graph each equation in the same coordinate plane. So we're going to have x and y axis, and we're going to graph one of our lines, and then maybe our second line looks like this. And so we've graphed them. Our second step, we're going to estimate the point of intersection. So where do the lines cross? And so we're going to identify what is the x and what is the y for the ordered pair of the point of intersection. And then lastly, we're going to check the point, this point of intersection, by substituting x and y in each equation of the original system. So let's take a look at an example. Okay, so in the problems for our first example, all we're looking at is checking the solutions to see if the ordered pairs are systems to the linear equations. So here's the ordered pair for the first problem we're looking at. And this is really what we're looking at in this example is really just step 3 of our process. Okay, so we can see that we have a system of linear equations. This equation here is a line, and this one here is going to graph out to a line. So we want to know, is this point a solution? Or does this point, when we substitute it into each of these equations, does it make the statement true? So the way we're going to do this, we're going to take the first equation, x plus y equals 6, and then we're going to substitute in our value for x and our value for y. Okay, so we're going to put in 5 for x, and we're adding it to 1 for y, and we want to know, does this equal 6? So we're doing a check. And sure enough, we can see 6 equals 6. So what this means is the point 5, 1, it's going to fall on this line. Okay, this is a point that falls on this line here. Now we need to check to see, does this same point fall on the second line? So we have 2x minus y equals 9. And we're substituting in our values for the ordered pair. So it's 5 for our x, and we're subtracting 1, which is our y, and we want to know, does the left side equal 9? Okay, so when we simplify, we end up with 10 minus 1, and we're questioning if that's 9, and sure enough, we see 9 equals 9. So this is also a point on this line. So if we think about the graph, if this is a point on both of these lines, and the lines intersect in one place, then this is the point that they intersect right here. So is this a solution? Yes. So for number 1, or for part A, yes, this point, 5, 1, is a solution to this system of linear equations. Okay, so our next problem that we're working on, so we're given the point -1, -5, and we want to know, is this point a solution to this system here, these two lines, okay? So we're going to substitute in -5 for our y. So I'm going to use the first equation here, -5 for y, and I want to know, is this equal to the right side, which is a negative x. So it's negative, and then x is -1. So it's a -1, and then I'm adding 2. Make sure you write this out, the entire step, the entire process, because a lot of you might make mistakes on the sign, okay? So we're checking to see, is -5 equal to 1 plus 2? And so -5 does not equal 3. So what this means is that this point, -1, -5, is not on this line. So -1, -5, is not a point on the line y equals -x plus 2. Now we already know that this is not a solution to the system, but we can still check to see if this point is on this line. So we're going to substitute in -5 for our y, and this is equal to, we're checking to see if it's equal to 3 times -1 minus 2. And so we can see -5, we want to know is this equal to, and -3 minus 2, sure enough, -5 does equal -5. So this point right here, -1, -5, is a point on this line. So -1, -5 is a point on the line y equals 3x minus 2. In order for this to be a solution, though, it has to be on both lines. So this point is not a solution to this system. Okay, in our second example, we're solving a system of linear equations by graphing. So we're going to go through the entire three-step process. So we're solving this system here. So we have two equations. I'm just going to call this first equation number 1. So I'm labeling it as number 1, and I am graphing it in blue. I can see that in order to graph this is already in slope-intercept form. So we can identify what the slope is and the intercept. So take a minute and do that. And hopefully you said we have mx plus b. So m is going to be a -1 on this line, and b is 5. So our intercept is going to be at 0, 5. Here's our point there. And then our slope is -1 over 1. So we're going down 1 to the right 1, down 1 to the right 1, down 1, right 1. Okay, and so on and so forth. And we're going to draw a line that goes through our points. Our second line, same process. In order to graph this line, we're going to look at the slope and we're looking at the intercept. If it wasn't in slope-intercept form, we're going to put it into slope-intercept form. So hopefully you said the slope is 2 and the intercept is -1. So the slope is going to be 2 over 1. Our intercept is here at -1, so 0, -1. Our rise, so we're going up 2 units and then we're going right 1 unit. Up 2 to the right 1. Up 2 to the right 1. Up 2 to the right 1. And then one more. There we go. So we're going to connect these dots to make this line, and we can see that it looks like the point of intersection is right here. And this ordered pair is going to be over 2 units on the x, and then we're going up 1, 2, 3 units on our y. So there's our point of intersection. So then our last step is we need to check to see if this point is a solution to both of these equations. So for our first equation, we have y equals -x plus 5, and we're using the point 2, 3 as our point of intersection. So let's substitute in 3 for y, and we're substituting in 2 for our x, and then we're adding 5. So we can see that 3 is equal to 5 minus 2, which is 3. So that checks out. So this line, this point does fall on our first line. Looking at our second line, y equals 2x minus 1. We're checking this point. So we have 3. We want to know, is this equal to 2 times 2 minus 1? And we have 3 is equal to 4 minus 1. Still asking that question, and we can see 3 is equal to 3. So this checks. So for your homework, step 1, make sure you're graphing each of the lines. Step 2, you identify the point of intersection. So approximate what that point is based off of your graph. And then step 3, you have to go through and check to make sure that point is on both of the lines and is the solution or the point of intersection between the two lines. Make sure you're using graph paper or really nice graphs that you're making on your lined paper with rulers and approximating each of your intervals pretty accurately.